Welcome to the detailed demo video of the Adaptive Interfaces MCE100 Mode C encoder. The MCE100 is a true digital altimeter displaying aircraft altitudes in 10-foot increments. It is also an encoding altimeter in that it can send altitude information to a transponder. It is called a Mode C encoder because a transponder reporting altitude information is said to be operating in Mode C. Before starting the demonstration, it may be best to review the operation of an altimeter. Almost all altimeters, whether mechanical or electronic, measure altitude by measuring air pressure. Air pressure is highest at sea level, and it decreases as one gets higher. The MCE100 measures air pressure with a solid-state pressure sensor and converts that pressure to an altitude with a microcomputer. Before being displayed, like a mechanical altimeter, the altitude is adjusted based on the local barometer setting. An important air pressure value to remember is called standard pressure. It is the average of air pressure at sea level. It is 29.92 inches of mercury, and it is the basis for all encoding altimeters. An encoding altimeter always reports an altitude of 0 feet when it measures an air pressure of 29.92 inches of mercury. It reports higher altitudes when it measures lower air pressures. Barometer settings are needed because air pressure changes with weather and is usually a little higher or lower than 29.92 inches of mercury at sea level. The dial of a mechanical aircraft altimeter allows you to adjust its altitude display to compensate for changes in air pressure. On the runway, an altimeter can be set to the actual field altitude. While in flight, an altimeter can be adjusted to the barometer setting given by a control tower or an ATIS report. The MCE100 display can be adjusted in the same way, only it's done electronically. Two things to keep in mind. While the MCE100 can display true altitude with 10-foot resolution, an altitude encoder, whether it's part of an encoding altimeter or a separate module, always reports altitude in 100-foot increments, and it also reports altitude only using standard pressure of 29.92 inches of mercury. The MCE100, like most altitude encoders used in general aviation aircraft, is used under 32,000 feet and reports altitudes to a transponder by using 10 digital signal lines. An aircraft's altitude can then be read by air traffic control every time its transponder gets interrogated. As stated before, altitudes are always reported using standard pressure. Altitudes are corrected by the air traffic control facility based on the barometer setting of the area in which the aircraft is flying. Since the MCE100 is both a digital altimeter and an altitude encoder, it displays true altitude based on a local barometer setting while sending altitude information to a transponder based on standard pressure. It's now time to start the demo. We'll start the demo by going over the functions that are available on the instrument and the buttons that are on the instrument. The functions are listed across the top of the instrument just above the digital display, and they have an accompanying indicator light to let you know which function is active. We'll start with the first function, which is alt. That's the altitude function, or the normal function of the instrument, and that is showing an altitude with 10-foot resolution based on a local barometer setting. The next function is MC, or Mode C. This is the raw Mode C altitude that's being sent to the transponder. It's using standard pressure and does not have any correction for a barometer setting. It's also given in 100-foot increments. The next two functions, BAR and FLD, are barometer and field, and these are used two different ways of setting the barometer setting on the instrument. The first one, BAR, is a direct barometer setting and allows you to set your barometer settings based on what you get from ATIS reports or from a control tower. The next function, field, allows you to set the barometer by setting your actual field altitude if you happen to be on a run-up pad. The last function, AA, is the altitude alert function, and we'll go into that later. To go over the buttons, there are four. The first one is the function button. That allows you to step through the functions on the instrument. Then you have an up button and a down button. And these have two purposes. They can be used when the instrument is set to a front panel display brightness setting. They can be used to adjust the brightness of the digital display when you're in the altitude reporting mode or the mode C mode. Any other modes, they're actually used to step the values up and down, and we'll see that later. The last button is the AA button, which stands for Altitude Alert, and we'll go into that a little later, but it's also used as an Enter button. Any value that's entered into the instrument needs to have the Enter button pressed in order for the instrument to actually save and retain that value. So let's kind of go through this a little bit. Like I said, we're in the main function right now, and we happen to be at 4,970 feet. If we press the button once here, the function button, we now see the mode C altitude. This is the altitude that's actually being sent to the transponder without any type of barometer correction. And this is the way altitudes get reported to a transponder. And again, at air traffic control, they will see that transponder value. They will know where the aircraft is located by radar and know the current barometer setting of that area. So now, like a mechanical altimeter, one can adjust the barometer setting. If you notice, because the default value of this instrument is reporting regular altitude, it will time out and go back to the altitude function, and you just saw that happen. And that'll happen after about a minute or so. That way you don't have false readings while you're in flight, or get confusing readings while you're in flight. But let's go ahead and go through some of this. Let's step the function to here, which is the mode C altitude that's being reported. The next function is the barometer setting. Right now we are at 30.14 inches of mercury, and that value can be adjusted up or down if you need to set with a local barometer setting that you get while you're in flight. Again, the instrument right now will not remember this value unless you actually press the AA button or the Enter button. Let's go ahead and do that. And the display will flash and the decimal points will light up to let you know that this is the new value that's being stored in the instrument. If we step through everything again, you'll notice that now, because the barometer setting has changed, the altitude has changed. Again, we want to go back to the proper barometer setting, and we can do this in another way. We can go to the actual barometer setting, or we can go to a known field altitude. Right now, because of the barometer setting changing, the instrument believes that it's at a field altitude of 4,920 feet. We're actually at 4,970. So let's go ahead and enter that value in. We can step our value up in 10-foot increments, up or down. Let's go back down to 4,970 and enter that value. And what the instrument is doing right now when you enter that value, it is adjusting its barometer setting based on the field altitude that you enter. So if we step through the functions again, we'll see that the barometer setting is back to 30.14 inches of mercury, and that's the proper barometer setting for our altitude. The next function we want to talk about is the altitude alert function. That's this function here. Altitude alert can be engaged by pressing the AA button while in flight. And the way altitude alert works is that if you're at a cruising altitude while you're flying, you can engage the altitude alert function. And once engaged, if you go above 200 feet above your cruising altitude or drop below 200 feet below your cruising altitude, the instrument will flash the display to let you know that you've drifted off of your desired altitude. We can kind of demonstrate that by tricking the altimeter by changing the air pressure. So what we'll do first is we will lower the air pressure a little bit to simulate going higher than the desired cruising altitude. And if you notice, the instrument does flash its display, and it can also drive an audio warning device or a warning light on the instrument panel as well. Let's go ahead and simulate going to low by increasing the air pressure a little bit. And again, you'll see that the display flashes to warn you that you've drifted off of your desired altitude. The altitude alert function can be disengaged simply by pressing the button again, and if it gets re-engaged, it'll be engaged at whatever altitude you happen to be at, and that'll be your new reference altitude and your new desired cruising altitude, hopefully. Now it's time to get into some of the optional settings of the instrument. To get into the optional settings, you press and hold the function button down for about 8 seconds. You'll notice that the instrument shows level 1, and for reference purposes the instrument is set to work on different menu levels. Menu level 0 being the normal operating mode of the instrument, level 1 being optional settings, and then there's also a level 2 that we'll go to that allows the instrument to be calibrated at different altitudes. Again, if you notice, if you wait too long, it'll automatically revert back to your altitude display. That's to keep numbers from showing up that you don't want to see while you're in flight. So let's go back and get into this level 1 option settings, and we can go through the different options of the instrument. Again, we hold down the function button for 8 seconds. We go into level 1. The first function that we have here is the brightness function, and this is allows you to have 3 different ways of setting the display brightness of the digital display. The first one being front panel, which means that the brightness of the display can be adjusted by the up and down arrows. We'll go back and show that in a minute. The next function, and we timed out here, so we'll just go back and do it again. We'll step through the functions now. As long as we're stepping through functions, the display will stay where it belongs. Right now we're in front panel control of brightness. The next function is a photocell control of the brightness, and in this case the instrument can be set to adjust its brightness based on the little photocell that's down here, and this allows you to adjust the brightness low when you're in a low light condition or nighttime flying, or increase the brightness when you're into bright sunlight. The next function is E, or external. That allows you to have an external control voltage go to one of the inputs in the back of the instrument, and that allows you to have a potentiometer or a brightness control knob on the instrument panel. So again, we can step through the various functions. Why don't we go ahead and set the photocell here. And we can go back to the main menu either by letting the instrument time out or stepping through the functions to a return to main function, which is like a double back arrow. Let's go ahead and do that. And right now the instrument display brightness is being controlled by the photocell. We can kind of trick that by shining a light on the photocell and showing you what the display will do when you change the lighting. As you can see, as you bring background light to the photocell, the display will automatically change its brightness. Let's go back and set that to front panel again real quickly, so that makes the demo of the instrument a little bit easier. We'll step it to front panel and go ahead and enter it that way. We can go to the next option setting by pressing the function button. This function, it's a little confusing right now, but it is AD off, and AD function is the auto dim function. And the way this works is if you're using your front panel controls to adjust your display brightness, you can also use the photocell to bring the brightness up if you go from a low light condition to a bright sunlight condition, or if you're in a bright sunlight condition then go to evening conditions, the instrument will automatically adjust its brightness one time. After that, you can still adjust the brightness with the up and down arrows. And right now it's a little bright, so we can adjust this up using the up and down arrow, or bring it down to the lowest brightness setting, which is actually the one that works best with the video here. Let's get back into the functions, or the optional settings. Again, we start off with the brightness, auto dim, which we can then set on or off. We'll leave it off. Next function is the SB function, or the strobe function. And older, well, not older, but some altimeters and altitude encoders and transponders actually use a separate digital line called a strobe line. And the ones that use this line, the transponder will pull active the strobe line when it wants information from the altitude encoder. And it doesn't look for information unless it pulls the strobe line down. And in order to make this work, we can actually change this encoding altimeter to either report information all the time, which it does when the strobe function is off, or if we set the strobe function on, it will only report altitude information when the strobe line is pulled active. Like I said, most newer transponders and altitude encoders don't use this strobe function because the digital information is always available. So the default setting on this thing is off. So we'll just go ahead and leave it at that. And that's about it for the optional settings. And the last setting that you can get when you press the function button is the return to main function. And again, that brings you back to menu level 0, or the normal operating mode of the instrument. There is another function or menu level that we can get into, and this is one that would normally only be done by an avionics shop with proper equipment, but it allows the instrument to be calibrated by an avionics shop at 0 feet and 30,000 feet, which is the normal place that most encoding altimeters will be calibrated at. So to get into that calibration function, we hold the function button down for 8 seconds. We get into menu level 1. If we press and hold the function button down again, we get to menu level 2. And there are two optional calibration settings. There's a calibration that can be done for 0 feet, and there's a calibration that can be done at 30,000 feet. And again, this can be done by an avionics shop that has the proper equipment for calibrating altimeters. And this allows you to have the instrument calibrated when you need it. After a few years' time, you may need to readjust it a little bit because some values may change a little bit. Again, this is a function that you normally wouldn't get into unless you were an avionics shop. Plus, there are some safeguards on the instrument that if you inadvertently get to this level, which you pretty much have to do by holding the buttons down for a long time. And again, we'll get back to the here. And the way the instrument works, it has a few safeguards in it. Right now we're at almost 5,000 feet. If I attempt to do a 0-foot calibration and I press the enter button, you'll notice nothing happens. The instrument is set up so that the values, the air pressure values, have to be pretty close to an actual 0-foot pressure or a 30,000 foot pressure before the instrument will even allow itself to be calibrated. So that's a little bit of a safeguard in case somebody gets into this menu and starts pressing buttons when they're not supposed to. Again, this is something that would normally be done simply by an avionics shop. So we can step through the functions here. In this case, we actually have two return functions. We have a single back arrow, which will bring us back down to menu level 1, and we have a double back arrow, which will bring us back to menu level 0. Let's see what it does when it goes to 1. This will bring us back into our other optional settings menu, and then we can go back to our main level normal operating mode. And that pretty much covers the operation of the MCE100. and thank you for watching. Thank you very much.